The story of humanity is a story of speed. From our earliest days, we've been driven by the desire to move faster, to reach farther, to connect distant places and people. We walked, rode horses, built trains, cars, and planes, each step shrinking our world, each invention bringing us closer together and redefining what was possible. Now, we stand at the edge of a new frontier, hypersonic flight, where the boundaries between Earth and space begin to blur, and the very concept of distance is transformed. China has just announced a successful test flight of a hypersonic jet, a technological achievement that has captured the world's attention and imagination. This isn't just fast, it's a leap that blurs the line between aviation and space travel, opening doors to possibilities we once only dreamed of. The jet reached Mach 6.56, over 5,000 miles per hour. At these speeds, the world becomes astonishingly small, and time itself seems to bend. Imagine New York to Los Angeles in under 30 minutes. Journeys that once took hours could soon be measured in mere moments. This is more than a number, it's a paradigm shift. It's a signal that the future we've envisioned is rapidly becoming reality. The age of hypersonic travel is no longer a distant dream. It's happening now, unfolding before our eyes as nations race to unlock its potential. China's breakthrough places it at the forefront of a global race to master hypersonic flight, setting new standards for innovation and ambition. For decades, such speed was science fiction or top-secret military fantasy, the stuff of movies and classified projects hidden from public view. Pushing an aircraft to these velocities creates unimaginable heat and pressure, testing the limits of physics and human ingenuity. The air can become plasma, and only the most advanced materials can survive. Every component must withstand forces that would destroy ordinary aircraft. Building a reusable, controllable vehicle at these speeds is an engineering marvel, requiring breakthroughs in design, materials, and control systems. China's success suggests they've solved some of the toughest puzzles in aerospace, achieving what many thought impossible just a few years ago. The implications ripple across the globe, signaling not just technological capability, but a new era of competition and cooperation among nations. In a world where information moves at light speed, our physical movement still lags. Hypersonic travel could finally close that gap. Hypersonic flight could change that, redefining logistics, business, and military power. The way we move goods, people, and ideas may never be the same. We're witnessing the dawn of a technology that will reshape our planet, connecting cultures and economies in ways we can only begin to imagine. The sky is no longer the limit, it's the new ocean, and we're building ships to cross it, forging new paths for humanity's journey. The race is on, and the world is watching. Every nation, every innovator is now part of this unfolding story. What comes next could change everything. The next chapter in the story of speed is being written right now. The future of speed has arrived, and it's only just beginning. To truly grasp this incredible achievement, we first need to understand what hypersonic flight actually means and why it's so revolutionary. Subsonic flight is anything below Mach 1, the speed of sound. This is where commercial airliners operate, gliding smoothly above the clouds at speeds we consider fast, but are actually just a fraction of what's possible. Supersonic flight ranges from Mach 1 to Mach 5. This is the realm of fighter jets, where breaking the sound barrier is routine, and the roar of engines signals incredible velocity. But hypersonic? That means speeds above Mach 5. At this point, you're entering a completely different world, where the rules of flight and engineering are pushed to their absolute limits. At hypersonic speeds, air molecules slam into the aircraft so hard and fast that they compress and heat up, reaching temperatures that can easily melt steel and other metals. Traditional jet engines simply can't function here. The incoming air is far too hot and moving too quickly for normal combustion to occur. That's where ramjets and scramjets come in. These special engines use the vehicle's own speed to compress air for combustion, making hypersonic travel possible. Igniting fuel in a scramjet is like trying to strike a match in the middle of a hurricane. Everything happens in milliseconds, and the margin for error is razor thin. Heat becomes a massive challenge. The nose and leading edges of the aircraft can reach temperatures of thousands of degrees Celsius, threatening to destroy the vehicle. Only the most advanced ceramics, carbon composites, and specially engineered alloys can survive these extreme conditions without failing, protecting not just the aircraft's structure but also its sensitive electronics and onboard systems from this intense heat is a major engineering hurdle. Control is another huge challenge. At Mach 6 and beyond, even the slightest adjustment to the flight controls can have dramatic, unpredictable effects. The air itself behaves in strange ways, acting like both a fluid and a solid, creating shock waves and turbulence that are difficult to predict or manage. That's why flight control systems must react instantly and with extreme precision, using advanced algorithms and real-time data. Mastering propulsion, materials science, and aerodynamics is the key to unlocking hypersonic flight, a challenge that has taken decades of research and innovation. It's a dangerous dance with the very laws of nature. Few have ever succeeded in this arena, until now. China's recent test shows that the frontier of hypersonic flight is finally within reach, marking a new era in aerospace technology. The science of speed is being rewritten before our eyes, and the possibilities are truly limitless. China's hypersonic jet stands out for its design. Unlike the needle-nose shapes of sci-fi, it's bulky and wide. This isn't a flaw, it's a solution. The wide, flat body generates lift in the thin upper atmosphere, using the whole aircraft as a wing. This lifting body design rides its own shockwave, creating efficient lift and spreading out heat. The shape allows for more internal space, room for engines, fuel, and even cooling systems. It's robust, potentially reusable, and can carry significant payloads. Unlike missile-like test vehicles, this jet could one day carry people or cargo. China's design hints at ambitions beyond the military. It's a blueprint for hypersonic passenger and cargo travel. The future of flight may look very different, and much faster. The US has long led in high-speed flight, from the Bell X-1 to the SR-71 Blackbird. Today, America's hypersonic focus is military unmatched reconnaissance and rapid payload delivery. Projects like the classified SR-72 aim for Mach 6+ speeds, making interception nearly impossible. Private companies like Stratolaunch test hypersonic vehicles using air launch methods, gathering vital data. This dual approach, secret military programs and open private innovation, defines the US strategy. The goal: maintain a strategic edge in a new era of warfare. While civilian hypersonic travel is a dream, most funding targets military dominance. The US wants to ensure its military can operate and win at hypersonic speeds. The race is about more than speed, it's about global power. The stakes have never been higher. Russia is another major player, focusing almost entirely on military hypersonics. Its avant-garde hypersonic glide vehicle can maneuver unpredictably at extreme speeds, evading missile defenses. The Kinzhal, an air-launched ballistic missile, reportedly reaches Mach 10 and has seen combat use. These weapons are designed to bypass advanced defense systems, creating a new strategic threat. Russia's doctrine is clear: hypersonic speed as a weapon of war, not for transport or reuse. Unlike China's reusable jet, Russia's systems are single-use and expendable. The priority is immediate military advantage. The arms race is accelerating. The hypersonic race reveals two futures: military supremacy or civilian revolution. The US and Russia focus on weapons, faster missiles, unstoppable reconnaissance. Their programs are about deterrence and strategic balance. China, meanwhile, pursues dual-use technology. Its bulky jet hints at ambitions for both military and civilian hypersonic travel. Mastering reusable hypersonic platforms could give China a lead in both defense and a future commercial industry. The stakes are high. Hypersonic weapons could destabilize the world, but hypersonic travel could connect it. Technology is neutral. Its impact depends on our choices. The path we choose will shape the world for generations. Will hypersonic speed divide us or bring us closer? The answer is still unwritten. Hypersonic technology could transform our world far beyond the battlefield. Civilian travel would be revolutionized. London to New York in hours, not days. Global business, tourism, and relationships would change forever. Logistics would leap forward. Imagine critical supplies delivered worldwide in just hours. Hypersonic cargo drones could create a truly global, on-demand supply chain. Space exploration would benefit too. A hypersonic jet could serve as the first stage to orbit, making launches cheaper and more routine. Defense applications are equally profound: real-time surveillance, rapid global deployment, and new strategic weapons. The possibilities are immense, for good and for ill. Hypersonic speed could shrink the world or make it more dangerous. The technology is here. How we use it is up to us. The next era of human progress or peril may be measured in Mach. The world is about to get a lot smaller and a lot faster. The promise of hypersonic flight is dazzling, but the challenges are immense. We're in the early days, like aviation a century ago. Turning test flights into safe, reliable, affordable transport will take decades. Safety is paramount. Hypersonic vehicles must match the reliability of today's airliners, despite extreme heat and speed. Economic hurdles loom. Exotic materials and advanced engines are costly. For hypersonic travel to be practical, costs must drop dramatically. Environmental and regulatory questions remain. What about sonic booms or effects on the upper atmosphere? New international rules and air traffic systems will be needed. Solving these challenges is as vital as the engineering itself. The road to hypersonic travel is long, but the destination could change everything. Imagine a world where hypersonic travel is not just a dream but a part of everyday life. A world where crossing continents at incredible speeds becomes routine. The morning commute could mean flying over entire oceans, connecting cities and people in ways we once thought impossible. Families could reunite across continents for the weekend, making global travel as simple as a road trip to a neighboring town. Cities transform into interconnected hubs, just hours apart, shrinking the world and bringing distant cultures closer together. Global business and innovation accelerate. Surgeons, engineers, and creative teams can collaborate face-to-face worldwide, all within a single day, sparking new ideas and breakthroughs. The world feels smaller, more dynamic, and more unified than ever before, as people from every background interact and share experiences. But the same technology that brings us together can also create new divisions and challenges. Hypersonic weapons raise the stakes of conflict, making global security more complex and widening the technological gap between nations. We must be wise stewards, working together to create new norms, agreements, and treaties to manage these risks responsibly. The hypersonic age reflects our nature as explorers, innovators, and tool builders, always striving to push boundaries. It's a story of reaching for the next frontier, of daring to go where no one has gone before. The hypersonic jet is more than just technology. It's a symbol of our relentless quest to go faster, farther, and to connect our world. The future it creates is not yet written. Its possibilities are as limitless as our imagination. It's up to us, together, to decide what that future will be and how we will shape the hypersonic age for generations to come.